Hello, welcome to lecture 11. Today I am going to talk about polynomials. This is mathematics for class 9 based on NCERT syllabus. My name is Sangam Banerjee and my details are given below. Okay, today I am going to talk about polynomials. What is polynomial? Polynomial is a mathematical expression or equation consisting of variables, also called indeterminates, and coefficient. It has variables. Variable I labeled it as x or y or anything. And it has coefficients. This the coefficient before these variables. These 2 and 3 are the coefficients. That involves only operation of addition, subtraction, multiplication, and non-negative integer exponent of variable. Here we will consider only positive in this chapter. And no divisible by variable. This equation you write and you don't divide by any other variable. And not an infinite number of terms. That is, here there are 3 terms. You can have as large or as small, but not infinite number of terms. Okay, n can be very large, number of terms can be very large. So here 2, 3 are the constant coefficients and 4 simply is a constant. These are the operations and x is the variable. So as I said, these coefficients can be any rational numbers, it can be fraction also. And here x and y are the variable, this 2 and 3 by 2 are the coefficients and 7 is a constant. So you can have polynomial which is linear, that is, this is a linear term, x to the power 1. So it is degree 1. Or you can have a quadratic, that is x to the power 2, or you call it degree 2. Or you can have a cubic polynomial, that is x to the power 3, so you call it degree 3. Or you can have a quartic polynomial, that is with x to the power 4, and you call it degree 4. And this coefficient a, b, c are rational numbers from anywhere minus n to plus n. And n can be small or big or whatever. So if you have only one term, it is called monomial, and if it has 2 terms, then it is called binomial. There are 2 terms, so this is binomial. And if you have 3 terms, this is 3 terms in an equation, then it is called the trinomial. And then there is zero polynomial, that is any real number. This is 6, root 2, pi, 0, constant terms. But you don't have degree of zero polynomial and is not defined. Okay, so some constant is always called a zero polynomial, but this zero polynomial is not degree 0. Okay, it is not a polynomial, it is a constant number. So here we take some example. Suppose qy is a polynomial, that is q is a function of y. This is the equation. It is 3y cube minus 4y plus square root 11. So what will be the value of qy at y equal to 2, that is q of 2, okay, at y equal to 2. So I substitute y equal to 2 here, so y cube becomes 8, this 4 into 2 is 8, and I get this value 16 plus pi. Now if px is equal to x minus 1, then if I put a value x is equal to 1 here, then p of 1 will become 0, that is x is equal to 1 minus 1, 0. So we call that x is equal to 1, 1 is a 0 of a polynomial px. Okay. Similarly, suppose you have p of x is equal to x square minus 2x, which I break into this, I take x common, x minus 2. So this will be 0 for x is equal to 0, suppose 0 into any number is 0. Or if x is equal to 2, 2 minus 2 is 0, so this becomes 0 into x is 0. So this p of x is equal to 0 at x is equal to 0 or x is equal to 2. Okay. If x is equal to 0, x is equal to. Now exercise from your textbook, there is exercise 2.2. It says if p of t is equal to this polynomial, then p2 is what I substitute 2, t is equal to 2 here, and I get, if I do this, I get equal to 4. Similarly, if p of 1, if t is equal to 1, I substitute here, 1 square is 1, 1 cube is 1, so 2 plus 1 plus 2 minus 1, this is again 4. So p of 2 and p of 1 for this equation is same, equal to 4. And if suppose I have a polynomial, this px, I have factorized it here. We will see in this lecture only what factorization means. So here means this 0, p of x is equal to 0 for x is equal to 1, that x minus 1, so if x is 1, 1 minus 1 is 0, or x equal to minus 1. Okay, so this, so p of 1 and p of minus 1 will be 0, and but p of 2, suppose if I put 2, then it is not 0, it is. Now we will discuss division of polynomials. Okay, suppose you have this polynomial and I divide by, this is your quadratic polynomial and this is your linear polynomial. So how do you do this division? You write the dividend here and divisor here, and divisor is x plus 1 and this dividend is 3x squared plus x minus 1, and our aim is to eliminate this term till I find some remainder or remainder is 0. So x plus 1, so I have to remove this 3x squared, so I have to multiply this x by 3x to get 3x square here. This is remaining, so again I multiply by 3x, so I get here. So now I can remove this, I can eliminate this 3x square, okay, by subtracting. So x minus 3x will be minus 2x, and this minus 1 I have brought it down. So now I again, to make it 2x, this is x, so x into 2 is 2x. So here it is minus sign, so x into minus 2 I will do, because minus time minus of minus become plus, so plus 2x and minus 2x will cancel, so this will also get cancelled. Minus 1 plus 2 is 1, so the remainder is 1. So therefore I can write this dividend, this polynomial 3x square plus x is, this is, how do you write? You write whatever dividend is, your divisor into quotient plus the remainder. So this is what I have written there, dividend is divisor times quotient plus the remainder. So here same thing I have written, dividend is equal to divisor into quotient plus remainder. So division algorithm, this is what is the algorithm? Any polynomial is nothing but this divisor, okay, this px is a dividend, say this is quotient, and then rx is a remainder. Here one can show also whether rx is 0 or non-zero also we can find out, and if suppose this is 0, then we say that okay, this divisor is a perfect factor of this dividend. We will come to it. Now you know this is the equation given, and you know this dividend is this divisor into this quotient plus remainder. So suppose if I put x is equal to x plus 1, I take x is equal to minus 1 and I substitute here x is equal to minus 1 here, I will get 1 remainder. And if I substitute x is equal to plus 2 by 3, this is minus, so if I take plus 2 by 3 and I substitute here, again I will get the remainder 1. Okay, so here I have done it here. Okay, x is equal to minus 1, I substitute, I get remainder 1, and here again I get. So here I am trying to say that if rx is equal to 0, if suppose this is 0 and this is, there is no remainder like what we have found here, then qx is a factor of px. Otherwise qx is not a factor of px because some remainder is remaining. Okay, so let us go now to something called remainder theorem. Okay, now let us discuss remainder theorem. It says that if px is a polynomial is divided by x minus a, okay, this is one of the factor, and if you substitute x is equal to a here and if you get pa equal to 0, then you don't have the remainder. So if you have given a problem to find the remainder by dividing two polynomial, then if you know one of the factor, you substitute and you will get the remainder. Okay, so we will see this in examples also. So here the proof is, if this is a polynomial, x minus a is one factor and this is a quotient, this is the divisor, this is a quotient, and this is a remainder. So because now since x minus e is a polynomial of 1, therefore this rx should be a degree less than 1, that is 0 degree. So rx will be, say, some constant r. So if I put x is equal to a, that is a minus a, this is 0, so 0 into any number is 0. So p of a will be equal to r. Okay. So anyway, these are used, we will see some example here. Here example 9, find the remainder when this equation is divided by x minus 1. So what I have to do, I substitute x is equal to, this is x minus 1. So x is equal to 1. So that this becomes 0. So for x is equal to 1, I substitute here. So p of 1 is, this is 1 plus 1 minus 2 plus 1 plus 1 is equal to 2. So the remainder will be 2. So if I divide this by this, instead of this long division, and we found the remainder, you simply can substitute the value p1 and whatever you get the value, it is the remainder. Okay. So now is q of t, this is a polynomial, is it a multiple of qt plus 1, is it multiple? That means r is 0. Thus we can only say 2t plus 1 is a multiple of this qt if and only if q of minus half, this t, this is, you have to make this 0, no? So t, if you multiply this t, if you subtract minus half, to this will become minus 1, minus 1 plus 1 is 0. So if q of minus half is 0. So I substitute this q of minus half here, okay, this is 4 into minus half to the power cube, then 4 into minus half square, then t equal to minus of minus. So if you do some little algebra, I'm not going to go through this kind of very simple steps. This multiplication, division, addition of number you should be knowing by now, okay. So this is 4 into 2 to the power 3 is 8. So 4 divided by 8 is half. So you check it, freeze and check it and see it. So you have, this is equal to 0. So you can say 2t plus 1 is a factor of qt. And qt is a multiple of factor 2t plus 1. So now we will discuss factorization of a polynomial. We will start with a very simple one with a trinomial, that is quadratic polynomial. And quadratic polynomial means ax square plus bx plus c. This is a quadratic always. This is general form of a quadratic polynomial. So factorization means that I write this polynomial as a some multiple of few factors, okay. And if the multiple of the factor doesn't give this but there is some remainder, then of course then they are not the multiple factor. So we will see how to factorize a equation, and factorization of equation we will see how it helps in solving few problems in this lecture. So I can write this ax square plus bx plus c is equal to, okay, this is a quadratic in terms of linear now, okay, this is a linear. So I write this is px plus q, this is a linear equation. This p is unknown, q is unknown. Suppose your a, b and c is given, okay, so this p is, we have to find what is this q. Then this is px plus q times rx plus s. So there are two linear to get a, this is degree 1. So if you multiply two equation of degree 1, you get degree 2 equation. And this a, b and c can be expressed in terms of p, q, r and x. We'll see how one get it. So this is px plus q into rx plus s. I take this px, multiply by this, then add and multiply by this, then take q and multiply by this, and this q and multiply. So this is what I have done here. Px into rx is prx square. So you follow as I have marked here, and then you can write this two term as ps, x is a common here. So I write x, I remove it outside, and this qs, and I can call this pr. This is now you got a quadratic equation. If pr is a, then ax square. If this is b, then this is bx, and if qs is c, you have this, okay. So this will be useful as we proceed, you will see it. So but you note here this ps into qr I can write as pr into qs. So like a into b is b into a. So this pr is equal to a and qs is equal to c. So pr dot qs is equal to ac, okay. So let us see one example from what we have learned so far. Factorize 6x square plus 17x plus 5, okay. So here we are doing called middle term splitting. So here you see I have this bx, I have split it into here, okay, ps into x plus qr into x. So this is the middle term splitting, okay. So what I do, in this also I will do middle term splitting, okay. So getting an idea from here, okay, this is the splitted and this is a product. Product is a into c, that is this ax square plus bx plus c. So a into c, that is 6 into 5, 30, okay. And I will split this middle part in such a way that I have the same product, 30, okay. So 6 into 5 is 30, I know, okay, a into c. and I know that I factorize this 2 into 15. This 30 I can write 2 into 15. So I know that 2 plus 15 is 17. Okay, this is, I have written here AC, this PS plus QR. Okay, this is 17. Okay, so actually what do you mean by factors of 30 is 1 into 30 is 30, 2 into 15, 3 into 10. So 5 into 6 is 30. But what combination will give me 17? This is the only combination. This marked in arrow will give me 17. So I break 17 into 2x plus 15x. Just go through it if you are not understanding, okay, or freeze it and try to see it. So this 2x is common. So 2x into 3x is 6x square. 2x is here. 5 is common. 3x. Now 3x plus 1 is common. So I write 3x plus 1. 2x plus 5 I write it here. So this is how you do the factorization by splitting the middle term. Okay, now we will state factor theorem. What is factor theorem? If px is a polynomial of degree n greater than 1 and a is any real number, then x minus a is a factor of px if pa is 0. So this is a factor, this x minus a is a factor only if pa is 0. If you have a remainder, then it's not a factor. Okay, and if pa is equal to, or vice versa, if pa is equal to 0, then x minus a is a factor. Okay, so it's a vice versa. So we can prove this from the remainder theorem. Remainder theorem states that this polynomial px is nothing but this is the factor x minus a times some quotient. Okay, this quotient can be again some factors plus rx. This is a remainder. So for x minus a to be factor, we want this pa equal to 0. So that means px is equal to x minus a into qx. So if at x is equal to a, then pa is 0 because a minus a is 0. Okay, and if x minus a is a factor, then px is equal to, this is a factor, this polynomial, this is a polynomial, x minus a is a factor, and this is some polynomial of order less than px, then pa is equal to 0 because if I put x is equal to a, pa is equal to 0. So if x minus a is a factor of px, then pa is equal to 0. Okay, if it's not a factor, some remainder, then you will have some remainder p of a equal to some r. Okay. Okay, now we are going to solve quadratic equation by completing the square. Solving means we will try to factorize. So earlier we did by splitting the middle term, but here we will make a complete square, that is some factor square, and let us proceed. You will understand what I mean. I will show you one trick. You make this coefficient 1 by dividing it by 6. So if I divide by 6, this is x square, 17 by 6 into x plus 5 equal to 5 divided by 6. So all term I have divided. So I call this as the first term. Okay, this is the middle term and this is the last term, and I only consider coefficient. Okay, so we will use a trick. We will write the last term. This is the last term LT. Okay, is equal to middle term the whole square divided by 2 square. Okay, or middle term by 2 the whole square. Okay, and this always work. So this last term, the middle term the whole square is 17 by 6 divided by 2 square is here. So if I substitute this last term from here, this, and I take this one 5 by 6 to the right hand side, it becomes minus 5 by 6. Since I have added this, I have to add there to balance it. This is what I have written here. Suppose I put a new constant c prime, then I put here also c prime, and this c becomes here minus c. Okay, so now I get this, and now I can write this as a square. This is x plus 17 by 12 the whole square. That is big. Why? Because if you expand this, is x square plus 2 into x into 17 by 12, 2 and 12 cancel the 6, so it is 17 by 6x, then 17 by 12 the whole square. Okay, equal to minus 5 by 6, and here 6 will go down, 6 into 2 is 12. Okay, so now I have this x plus 17 by 12 square is equal to, this is a number which I can always calculate, use cross multiplication and so on and so forth. You just use a calculator also. And now you have this x plus 17 by 12 the whole square is, if I simplify it here, just freeze it and see how I have simplified, you will get 13 by 12 the whole square. So now this is square. So if I take a square root, because whether it is plus or minus, okay, minus into minus is plus, square means what? Same number, a square is a into a. So if it is minus 1 here is minus 13 into minus 13 squared is same as 13 into 13, okay, or 13 square. So for a square, minus is always, so we do not know whether it is plus or minus, so I write here plus or minus 13 by 12. So I can write this x plus 17 by 12 is equal to plus or minus 13 by 12, because as I said, plus a square is equal to a square and minus a square is also equal to a square. So I do not know whether it is plus or minus, so that's why I write here plus or minus. So x is equal to, I bring this to the right hand side, minus 17 by 12 plus or minus this, 12 is a common. So x is equal to minus, so I take either plus, minus 17 plus 13 or minus 17 minus 13, okay. So from here you get minus 4 by 12 and from here you get minus 5 by 2. And this minus 4 by 12 can be written as 4 goes 3 times minus 1 by 3. So x is equal to minus 1 by 3 or x is equal to minus 5 by 2. Okay. So this is what we had in earlier also. So the factor will be 3x plus 1 into 2x plus 5. Okay. This factorization of this one. Okay. So that's what I have said here. Use factor theorem, that is 3x plus 1 and 2x plus 5 are the factors of px, and check p of minus 1 by 3 and p of minus 5 by 2 is equal to 0. Check it. So here I have checked for minus 1 by 3 and I indeed get 0 here. Similarly, check for p of minus 5 by 2 and you will definitely get minus 0. You will get 0. So we have discussed two methods, that is splitting the middle term or making a perfect square. Or another way, suppose you have a quadratic formula. Suppose you have a quadratic equation and you want to know the solutions or the factors. Okay, this is the third method. Directly if you put the values, this coefficient a, b and c, you can get the values of x. So here again what I do is I use the previous method where I divide by a all throughout. So this is x square, b by a x, c by a. And then I replace this last term to make it a perfect square. So again here I write the last term is equal to middle term divided by 2 the whole square. So middle term is b by a divided by 2 the whole square. This is my last term. I still keep here my c by a here, and since I have added here I put same value here, okay, because to balance the equation. So this is from here. Then I have this c plus a here. Okay, I have to take it this side. So if I take this term and I put this thing here, I will get, this is x plus b by 2a square, this one is equal to b by 2 and this minus c by a, if it comes in the right hand side. So I have this. So if I simplify this as a b square, here I have done it. So I will get b square minus 4ac by 4a square. Okay, just go through it. And now this square is there. So since I have removed the square, I have taken a square root of this term. So that means I will have again here plus or minus. Okay. So this, if I have taken square root here, I have taken here also square root. But I do not know whether it is plus or minus. So I write plus or minus here. And this is b square minus 4ac. So this again I can simplify square root of b square minus 4c by 2a. So x is equal to, now x, you get this one here. So x is equal to minus b times plus or minus square root of b square minus 4ac by 2a. So this is the formula for the unknown in the quadratic equation. Suppose you have given a quadratic equation with coefficient a, b, c, then you can find what the variable x is. So once you know x from here, then you can have two factor, x minus of with this plus and another x minus with this minus sign. Okay, we will see it in the next few pages. So now let us solve the same problem which we did earlier for x from this quadratic equation. Solution for quadratic equation is x is equal to minus b plus or minus b is square root of b square minus 4c by 2a. So I substitute all these values here. So x is equal to minus 1 by 3 with the plus sign here, and with the minus sign here it is minus 5 by 2. So you see all the factors are exactly same in the three methods. Now example 15, factorize x cube minus 2x square plus 142x minus 120 is equal to px. Okay, so how do I do it? I just guess. One can guess also. For x is equal to 1, we know that px is equal to 0 if I substitute. So then I know that x minus 1 is a factor of px, one of the factor. So here we have seen, by putting x is equal to 1 here, I have seen that this, if you add them, it is 0. So write this polynomial in term of this factor x minus 1. It is very easy to see here. If you write x minus 1 for this has to be x square. Okay, then x square into minus 1 is minus x square. So similarly, you see here, you can understand it very easily. This 120 is common, x minus 1. So taking x minus 1 common, x minus 1 is common. I have x square minus 22x plus 120. Okay. So now I factorize this by splitting the middle term. That is 10 into 12 is 120 and minus 10 minus 12 is minus 22. So you will get this factor, three factors, x minus 1, x minus 10 and x minus 2. Now exercise 2.4, determine which of the following polynomial has x plus 1 factor. That means if I put x is equal to minus 1 in the polynomial, I should get 0. So for this it is there. Just go through it, freeze it and see. You substitute this value, x is equal to minus 1 to the power 4 is 1. Minus 1 to the power 3 will be minus 1. Okay. This will be plus 1. This will be minus 1. Okay. All odd term will be minus. So minus time minus is plus. But minus time minus 3 odd, every odd will be negative, and even time minus are multiplied will be always positive. Okay, so you substitute here and you will find this. Now use the factor theorem to determine whether g of x is a factor of px. Okay, so this is g of x is x. So if I substitute x is equal to 3 in p of x, and if it is 0, then I say that gx is a factor of px. Just see it. This is what I have shown here. Now find the value of k if x minus 1 is a factor of px. So x minus 1 means, so now you put x is equal to 1 in px. So p1 is equal to k, x is equal to 1, x minus 1 is a factor. Then this is equal to no remainder, so equal to 0. So k is equal to minus will become plus 2 square root 2, and this plus 1 will become minus. So k is equal to okay, some example. These are very trivial. Again, it's too much of repetition. I am repeating this so that it is a kind of a revision. Okay, so factorize 12x square minus 7x plus 1. So again I do AC multiply 12 into 1 is 12, and I know this 2 into 6 combination will not give 7, but 3 into 4 is 12. This will give me minus 3 minus 4. So I write it, I get it. 4x minus 1 is common, so I remove it out. This is 3x minus 1. So here also you have a polynomial. So 2 into 3 is 6. So this is 7. So 1 into 6 is 6. So with 1 and 6 combination we can get 7. So here I have done it. Now factorize this equation and this polynomial. You can always try to find one, guess one factor. Say whether x minus 1 is a factor, that is x is equal to 1. I substitute here and find whether it is 0. If it is 0, then x minus 1 is a factor. But if it is not 0, then I try with equal to minus 1 is a factor. If plus 1 is not a factor, I will try with minus 1. And if I substitute here and if I get 0, then I say, okay, x plus 1 is a factor. I know that x plus 1 is a factor. So what is the quotient? This is the quotient. Again, I try to eliminate. You freeze and see it. Okay, x cube plus x square here. Okay, so I subtract this. So when I subtract this, I get minus 3x square minus x square minus 4x square. So you go through it and you get here 0. Okay, so one factor I got here, and now I factorize this to get the other two factor. So this x square minus 4x minus 5 I have written here. What is the factor of it? Again, 5 into 1 is 5, then 1 into 5. So this combination 1 minus 5 will give you minus 4. So here write 1x minus 5x. Okay, and these are the same thing. And you can factorize it as x plus 1 times of whole x minus 5. So this equation, now you have x plus 1 one factor, then another x plus 1 from here, and x minus 5 from here. Okay, so I can write as x plus 1 the whole square and x plus 5. Now factorize this again by guessing my method. If y equal to 1, whether it is 0, then y minus 1 is the factor. So since y minus 1 is a factor, this is your dividend. You try to get a quotient. You go through it. I have discussed this earlier, how you have to keep eliminating first 2y cube, then this y square, then this, till you get some remainder 1 or 0. Okay, but for factors you always have to have remainder 0. Here I have done the same thing. This is, I have taken this quotient, put it here, and again found its factor. So this quotient's factor times this factor is a factor of this equation. So the quotient factor is y plus 1 into 2y plus 1, and so this whole equation will have this y minus 1 one factor times y plus 1 times 2y plus 1. So these are some algebraic identity. X plus y the whole square is x square plus 2xy, that's 2xy plus y square. X minus y is x square minus 2xy plus y square, and x square minus y square is x plus y into x minus y. Or a square minus b square is a plus b into a minus b. Okay, and identity, this is again by the associative properties. Okay, x plus a into x plus b is x square plus a plus b x, which is common, plus ab. Here is a into b. Okay, so you expand this, you will find it here. Now evaluate 105 into 106 without multiplying directly. That is, I did not multiply directly. So I do 105, I write at 100 plus 5, and 106 as 100 plus 6. So now I do this 100 into 100, 100 into 6, 5 into 100, and 5 into 6. What I have written here. Okay, 100 square plus 5 plus 600 plus 5. So this is the answer. Now factorize this equation, 49a square plus 70ab 25. So this also I can write as a complete square. Okay, this is a square plus 2 times ab times b square, or I have written here x square plus 2 times x into y plus y square. Okay, so x plus y square plus 2xy. This is x plus y the whole square is this, x square plus 2x square plus y square. Okay, this is what it is. So I have here 7a, that is x, and y is 5b. So x plus y the whole square is x square plus 2xy plus y square. Okay, so this is the factorize 7a plus 5b times 7a plus. Now factorize this 25x square. So this is like a square minus b square. So a is 5x by 2, just see it, and this is y by 3. So a square minus b square is a plus b into a minus b. This is what I have written. A is 5x plus 2 and b is y minus 3. So now we discuss trinomial square, that is x plus y plus z. These are the trinomial. Okay, 3 terms are there to the power square. So I substitute, I call y plus z as t. So I get plus x plus t the whole square, I get this. Now substitute t equal to y plus z in t. And you can show that x plus y plus z the whole square is, from here you will get x square plus y square plus z square, and this. So example is given here. Okay, 3a plus 4b plus 5c the whole square. So I can expand using this identity here, 3a square plus 4b, here y square plus z square plus 2xy. Then I expand this, 3 square is 9a square, 4 square 16. This is a simplification. Okay, and similarly you use this identity and go ahead and freeze it and see it what I have done here. Okay, you can similarly write this. This I may be going fast, but of course you can always pause and listen slowly. Okay. Factorize this. This is where x square plus y square plus z square, what we have earlier done it. So I write in terms of a square plus b square plus c square plus 2ab plus 2bc plus 2cz. So this is what is your square. Okay. And this is how you factor. So if you this is square, so I write this 2 times. So if you multiply this, you can again get back this. But what about third degree? That is x plus y the whole cube. Is nothing but x plus y into x plus y the whole square. And x plus y the whole square is x square plus 2x plus y square, which we have shown. So you again expand here. You freeze it and see. All steps are given here. That means this one and this one you have to add. This one and this one you have to add. They are similar marking, means they have to add together and you get this. Okay. So similarly, x minus y the whole cube. So this one you can write plus and this minus y, similar thing. So x plus y the whole cube is x cube plus y cube plus 3xy x plus y, and x minus y the whole cube x cube minus y cube minus 3xy into x minus y. Okay, is x plus y, x minus y. These are plus plus, these are minus. Okay, so sign changes. Now we discuss another example, 5p minus 3q to the power cube. So I use this identity. Okay, this identity, that is, this is your a cube, 5 into 5, 25 into 5, 125 p cube. So just substitute, you write separately. If you get confused, you write what is a, what is b, what is c, or here I have written x, what is y, and similarly you substitute in this equation. These are the identity. If there is a minus, then in this one. Okay. So now evaluate 999 to the power cube. So it's very difficult to do it in the paper. So there is an easy trick. You write 1000 minus 1 to the power cube. So again you use this formula. Actually this formula can be also expressed as like this. Okay. You see it, you can do it yourself. So here what I have used here, this minus 3 of x square, y is 1, then 3 of x is 1000, then minus 1. Okay, minus, because y is here, it is minus. Okay, so minus into minus plus, and then again one more minus. So if you do this, and now you straight away write how many zeros? 9 zeros. Then here 3, 2, 6 zeros. Then this. Okay, plus, if this is minus, then plus, you do it. So you didn't have to do 999 into 999 into 9. So this is a shortcut of doing it. This is a trick of doing it. There is another identity in your textbook. Okay, identity 8 in page 48 of the book. That is x plus y plus z whole thing into x square plus y square plus minus xy minus yz minus zx whole thing is equal to x cube plus y cube z cube minus. So this is an identity. If you know, you can of course show this. So how do you show this identity is correct? So you expand it, x with x square, then x with y square multiply, x with z square you multiply, x with this, and so on. And similarly y also, and similarly for z also, you do multiply this, then this, and keep adding and subtracting according to the sign. Okay. Then for x I have written, this is for x I have written here, for y multiplication I have written here, and for z multiplication I have written here. And there are some common things like x y square, and here also is x y plus. So similarly there are many terms gets cancelled and only these terms remain, x cube, y cube and z cube, and this x y z. Here is also minus x y z, and here is also minus x y z. So there are minus 3 x y z. Okay, so this is one identity, and using this identity you can prove some examples. So suppose if x plus y plus z equal to 0, show that x cube plus y cube plus z cube is 3, x, y, z. So from here actually it is. So suppose if this is equal to 0, then this 0 into any number is 0. So that means this is equal to 0. That means this cube plus this cube plus this cube is equal to, I take it to this side, is 3x, y, z. Okay. We can always show this. That's why I have written arrow. Now exercise 2.5.14. It says without actually calculating the cubes. You don't calculate all the cubes here. Find the value of this. So I know this formula. X cube plus y cube plus z cube is equal to 3x, y, z. X is equal to here minus 12. Y is 7. Z is 3. So I put it here, this number. And I get minus 126. How I can put this? Because I know that x plus y plus z is equal to 0. Okay, that is minus 12 plus 7 plus 5 is equal to 0. So if this is 0, then the left hand side is 0. So I can straight away write this cube is equal to this. Now let us do this exercise. If an area of a rectangle is expressed as some expression, this equation, okay, area of a rectangle, then find length and breadth. So see, this is a degree 2, okay, a quadratic type of thing. So this is this will have area, okay. So if I factorize this, so I will have two factor here because it is square. So one factor will be length, another factor will be breadth, okay. So if I factorize this here, this area is length into breadth. So if I factorize it, this one, here I have shown, just freeze it and see, again same thing we have done, okay. 25 into 12 is 300 and 20 into 15 is also 300. So 20 minus 20 minus 15 will give you minus 35. See, here I have done it, you just go through it. So if you factorize it, you will have 5a minus 4 is common, so 5a minus 4 into 5a minus 3. So here I have written. So this may be the length, this may be the breadth, or this may be the length, this is immaterial, okay. So this is the area of a, this multiply this will give you this. This is the area of a rectangle. Then finally find the dimension of cube whose volume is expressed as this volume. So volume will have length, breadth and height. So I again factorize kind of thing, simplify it. 3x is common, I write x minus 4. So I require three factors. One is 3, then another one is x and x minus 4. So this can be length, breadth. So similarly, if the volume is given by this expression, then I can simplify it. This 4k I can take common, 4k, that is 4 into 3 is 12 ky square, then 4 into 2 8 ky, and 4 into minus 5 minus 20k. And now I factorize this portion here. I have shown how to factorize. If I factorize, I get 3y plus 5 and y minus 1. So now I can say this is length, and there are three factors, 4k, this 3y plus 5 and y minus 1. So this may be length, this is breadth, this is height. Okay, now we have finished the chapter on polynomial. So mostly we have finished, as I said, mentioned earlier, from chapter 5 to 13, and this is chapter 1 to 2. So there are another 4 chapters remaining, and we will see it in the next 2-3 lecture. We will complete the class standard 9 mathematics NCERT syllabus. So thank you and see you in the next lecture.